Today we're going to discuss how to interpret the reports that the software generates. When you take a sample report, we're going to be going over. This is the analysis of which averages the standard deviation values across all the different tasks except for the eyes closed. This is available at the end of each of the report and averages it for the phase, coherence values, and relative power, and magnitude, etc. So take a look at this example. I'm going to point out a few things to you. This is phase beta 2. On the bottom row here, you'll see the average standard deviation emanating from FP1 to all the other locations. In this particular instance, it's 1.83 standard deviations on average. And you can go along that bottom row and see what the average standard deviation is. If you are above 1.5 standard deviations in value, you get the orange. If you're between 0.5 and 1.5, you get yellow. If you're between minus 0.5 and plus 0.5, you get the white background. If you're between minus 0.5 and minus 1.5, you get the light blue. If you're below minus 1.5, you get the dark blue. In this particular situation, you can see the numbers are quite adequate across many of the connection patterns, except for T3 appears to be the weakest. If you look at these values here, the FPU, the FCPU, CPU, and PPU, these can be demonstrated to reflect the values in this upper set of variables called the frontal processing unit, the central processing unit, posterior processing unit, and the frontal CPU, which is particularly interesting. So you'll be able to pick out quite quickly if there's a problem in a particular area of the brain in terms of processing units. So for this example, we have a problem, a relative problem at T3, phase beta 2. And if we go up, we can see that the T3 problem relative to the other values is also remains weak. And we also have C3 as well as P3, all left hemisphere locations. And then we go up to the alpha frequency. We're in phase again, and now we see a particular problem with T3 phase alpha. You can see the many blues and where the connection problems are occurring, mostly to the left posterior region, the dark blues indicated. But you can see some other problems beginning to show up. The software, by and large, will pick out the values and variables that are predictive of performance, but you may want to go through this to see if there's a particular weakness that's not being picked up by the automatic selection, which intuitively would be important to address by creating a different variable and having that available for intervention. As we move up into the theta frequency, we continue to have some problems here. Theta is less undesirable as a intervention focus because sometimes it's negative and sometimes it's positive. So generally working with the alpha to beta 2 frequencies is preferred in the interest of efficiency and in terms of the efficiency of the sessions, because you don't have an unlimited number of sessions. As you can see, delta continues to show the problem at T3. Now we go to coherence values, and we again, there's a strong patient, a lot of good values, except for again the relative performance at T3 is weak compared to the other ones. That was beta 2. Now look at beta 1, the same pattern exists. Now we're extending that to C3. So by doing this type of analysis, you can really see where the weaknesses are. And now we're looking at coherence alpha, and again T3, C3, T5, and P3 and O1, all left hemisphere origin sites for these flashlight variables are particularly problematic. And again, the theta shows similar problems, again not to be the focus, and delta showing low values across the board. Now we look at the arousal variables. We can see that the magnitude of these delta, theta, and alpha, and beta 1 frequencies are relatively low, which is a problem because you don't want them low. You want them within a certain range. and that's true for magnitude and relative power, which are both showing the problem that are relatively low in values, which is problematic. Peak frequency appears to be adequate across the board. So now let's take a look at a particular task. We'll go to problem solving. Here we have problem solving phase, showing a lot of strength except in the posterior locations, it looks like. And then we go to beta 1, and again the posterior relationships show some weaknesses, particularly at C3. You have to know whether or not the C3 flashlight is related to performance, however, which the software will determine and recommend. We go to alpha, and we can see we have a phase alpha from T3 presenting a problem, as well as T5. And again, theta and delta showing the relative weaknesses, but less concerned about that. Go to coherence, showing relative strengths here. But again, we go to beta 1, and now we have some weaknesses posterior, and again from T3. So you can see T3 and these other left hemisphere locations are weak systems. And again, we get to the alpha, and we have particularly weakness in T3 again. And we go to theta, and similar sort of patterns for the delta as well. And now we look at the magnitudes, and they all seem relatively low. Relative power actually starts to stand out a little bit better here in terms of the alpha, but the beta is relatively low. Peak frequency is respectable. So this is what you can do. You take the overall pattern, and then you go to the individual task to see if that particular weakness shows up. And then if you think you need to design an extra variable to address it, then you can do so after this information has been gathered. Thank you for your time. Hope you enjoy it.